Today we're going to be learning about writing and evaluating scientific notation. And I understand most of you have talked about scientific notation in your science class recently, so we're going to try and, this will not be a very lengthy lesson. First of all, I need you to copy and complete the chart in your notes. It's all multiples, we're factor 5 times 10 to the fourth and then 5 times 10 to the third. So go ahead and copy that chart and complete it in your notes. Before we begin, I want to discuss what the meaning of scientific notation is. There's a couple rules for scientific notation. The first rule is that we have two factors. One of the two factors must be a number between, a number that is greater than or equal to 1. And it also must be less than 10. So this means that we will always have, the first factor will always have 1 or greater as part of the digit, but it could be 1 and 1/100th. Could be 5 and 2/10. But our first factor, we're going to have two factors. The first one must be a number that's greater than or equal to 1 and must be less than 10. So we're going to make that happen. And then the second factor must be a power of 10. That means 10 to the something power, 10 to the, let's say, 5th power. That's going to be our second factor. So scientific notation, we're using two factors, one that's a power of 10 and one that's a number between 1 and 10. And in scientific notation, we can also use a negative exponent to write a number that started out being between 0 and 1, teeny tiny number. For example, 79 millionths can be written as 7 9/10 times 10 to the negative 5 power. We took this decimal point and we moved it to the right 5 places here to place that decimal point between the 7 and the 9 to make that a number between, it has to be greater than or equal to 1 and less than 10, and 7 9/10 definitely meets that criteria. And then we're multiplying that by our second factor, has to be a power of 10, and in this case, when we start out with a tiny number, it's going to be a negative exponent, because what this means is 10 times 1 over 100,000. 10 times 1 over 100,000 is what this means. 1/100,000th. Okay, so let's check on if we can write these two examples down here. We have 21 millionths. So we've got to make that first a number between 1 and 10. That's 2.1 times 10. And how far did we move that decimal point? 1, 2, 3, 4 times 10 to the negative 4th power. And then this next one is 5.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, negative 8th power. And we know when we have a negative exponent, we have a very tiny number that we're dealing with. We can also go the other way with our scientific notation. We can write that scientific notation in standard form. So if we have 8 9/10 times 10 to the 5th, we know we can write that as 8 9/10, and we're going to multiply that times 5 places. 1, 2, 3, 4, 5. Place our decimal point and put a 0 in each of those places where we need to have a space holder. So that's 890,000. Okay, then we have 2 71/100ths times 10 to the negative 6th. We're going to take that, now notice where it's a negative 6th power, so we're going to have to move our decimal point the opposite direction to create our very tiny little number. So we were at 2 71/100ths, but now we're going to move that decimal point how many places? 6. So 1, 2, 3, 4, 5, 6. Place our decimal point fill a 0 in each one of those places, and our answer is 0.0000271. We can also multiply numbers with scientific notation by using commutative property. So our example of 3 times 10 to the negative 7th and 9 times 10 to the 3rd, if we multiply those together, we can reorder things, and we can take the 3 and put it right next to the 9, and then the 10 to the 7th times 10 to the 3rd, and that'll help us look at things because we know 3 times 9 is 27. Then we've got these two exponents, 10 to the negative 7th and 10 to the 3rd. Well, I know if I add those exponents, that's the same value, so I have 27 times 10 to the negative 4th. My answer is not done yet because I need a number between 1 and 10 right here. So I'm going to change that to 2 and 7/10. So 2 and 7/10 times 10 will get me 27, so I need to pull out that 10. And 10 times 10 to the 4th power would wind up being 10 to the 3rd power because we have a negative 3rd power. So we've got to add those two exponents. So final answer, 27 times 10 to the negative 3rd power. Then go ahead and complete these other couple examples that are here at the bottom of the page. Well, we can go ahead and reorder these. 4 times 6 times 10 to the 4th times 10 to the 6th, and then simplify from there. Another example is 7 1/10 times 8. The pen's not cooperating very well here. Times 8. And then we're going to multiply that by those two factors of 10. We have 10 to the negative 8th and 10 to the 4th. When I multiply those together, that's 10 to the negative 4th power, negative 8 plus 4. And then we have 7 1/10 times 8, which is 8 and 56 8/100. We need to move that decimal point. We need to divide by 10, so we got 5 and 68/100 times 10 to the negative 3rd power. So we're going to move our decimal point the opposite direction, making that 56 into 5 and 68/100. Okay, so we need to repeat the rules for scientific notation one last time. Scientific notation. Number 1, 2 factors. First factor has to be greater than 10. Less than 10, sorry. 10 is less than our factor, which is less than or equal to 1. So the number has to be between 1 and 10, but it can't be equal to 1. Any number between 1 and 10, but can't be equal to 1. And our second factor is a multiple of, as a power of 10, excuse me, not just a multiple, a power of 10. Scientific notation is easy, so good luck on your practice in class today.